It's an Xbox One, released in 2016, not exactly retro, but it doesn't work. So let's see if we can fix it. Right off the bat, just to go ahead and demonstrate the potential problem here, and connect up the power. You try to turn it on, turns on briefly, and then immediately shuts off. Hope that's coming through. So it is not happy. Let's go ahead and see if we can get this thing open. I don't know anything about opening up an Xbox like this. No obvious screws from the outside that I can see. So let's go ahead and see if we can get this thing open. According to an iFixit guide, you need to separate this bottom piece from the rest of the Xbox. So let's try to do just that. Fortunately, it's kind of bending my pry tool. Looks like there's no clips on the back. Most likely, clips are on the side. So let's try from here. I think I might use my metal tool, although it's not really great. That certainly sounds like a clip. There we go. There we go. Okay. So those clips on that side, so that's starting to come up. Let's see if we can do the same on the other side. This up a little bit. I definitely do not want you to open this thing. That much is obvious. I wanted to avoid prying it on the front, but that seems like it may be our best option. Okay. Looks like it's still held somewhere here at the back. You know what? We might have to remove this sticker. I am not sure what that is. Okay, there we go. All right. That is bottom of the Xbox removed. Next, again, having never taken one of these apart, not really sure where to start next. It doesn't just appear to fall out. Not sure if we need to remove these screws around the side, but I bet that's a good place to start. So I think next we'll try and remove these green screws. These are long. Oh. Warranty void sticker. Not that there is still an active warranty for this machine, so definitely not a concern. Quite like the green anodization coating on these screws. Certainly a little showing off a little bit there. I don't think there's any practical reason that these screws are painted or anodized. So what does that do? I don't think this metal is free yet. Oh, it does move around. Oh, all right. That is the Xbox extricated from its case. That is quite a nice sealed unit that they have going on. An all-metal internal chassis. Not sure if that's for shielding or cooling or both. In any event, let's see if this back cover will come off. I want to force it. Could be held on by additional clips. Alright, so just flipping it over, it looks like this cover now comes off. Aha. There we get a good look at the inside. Toshiba hard drive, fan, power supply, disk drive. Let's see what else we have going on. What I want to do is test the power supply and see if that's the cause, potentially bad caps or something else. Let's see how this is held in place. It's quite dusty. I wonder if these screws here hold it down. It's certainly a possibility. Let's go ahead and remove those and see what that does for us. I do quite like that all of these are the same bit. This is quite a tight screw. Okay, that's all of those on that side removed. Let's see if that power supply would like to go ahead and come out. It's certainly looser. It still feels like like it's being held down by something. I do wish this piece on the back would come off, although it looks like it's been, yeah, it's been welded onto this metal. So you can see down in here, there's these little tiny melted tabs where it's been connected to this outer frame. Well, let's see what removing some more of these screws does. Maybe the hard drive has to come out first. Yeah, everything is certainly looser now. Be careful when I turn this over. Don't want all the parts to fall out. Okay. Yeah, that seems to have loosened everything up. So, let's see. Here's the hard drive. Go ahead and disconnect that. Disconnect power and the SATA cable. Hard drive caddy. Looks like it has shock mounts. That's pretty cool. And now, let's see about this power supply. That's quite a compact little unit. See some markings on it. Looks like it's rated for 12 volts at 10 amps. So that's quite powerful for something so small. It connects with one cable to the main board. So we use our little tool here. The clip is kind of hard to get to because of the side of the case. That's an interesting choice. There we go. So that's the power supply. And I think I might try to see if there's a pin out, although if I had to guess, the black wires are ground and the gray ones are for the plus 12 volts. Let's move this unit out of the way. Let's focus on this power supply for a minute. So first of all, does this case come off? It certainly seems like it should. Could be held on by some clips. Here's a clip on this side. See what it looks like clips maybe on the inside too. Definitely no screws. There we go. It's starting to come apart. Looks like this clip up here relatched itself. Well, this thing is just being tricky. really does not want to come apart. It's even taped together or glued. Looks like there's a heat sink. Okay, there we go. And power supply is apart. Now, wonder how you get the board out. Power connector. Gosh. Okay. Okay, that is our power supply removed from its internal case. It's made by Light-On, which normally makes pretty good supplies. Yep, so the gray wires are plus 12. You can see the markings here on this board. So we have plus 12 and we have ground. So let's get out our voltmeter and see and goes without saying, if you do not know what you're doing inside of one of these power supplies, I recommend to leave this to others. But for the sake of the channel, let's see what happens. So I think I'll go ahead and connect the power. And then I'll just probe the two solder points here on the bottom of the board. So go ahead and carefully connect that. I don't see any open exposed contacts. Okay. So now let's test. I am not getting 12 volts. So I wonder if it knows that it's not connected. Oh, possibly this cord fell out. Let me unplug first over here, and I will plug it back in. Okay. All right. Let's give that another test. 12 volts and ground. It looks like a clean 12 volts to me, just slightly under, although that could be the probes. So that doesn't appear to be a problem. Unplug that. Unplugged, as you can see. So what I'd like to do is reconnect it to the chassis. Make sure we know where our power button is. Where is our power button? Power switch. Okay. Power button's right here on the front. So I can press that. And move that a little bit. Let's plug in power supply back into the board. Just let that sit. I'll let it sit on the metal. Okay. And reconnect it. see if we have the same behavior. Okay. Let's see if we can probe 12 volts and ground. Bring our voltmeter back into view. You know what, I think I'll let this sit somewhere in the case for a ground. It's not really a great place. I'm going to hold these two probes on and let's see what happens to the 12 volt when we try to turn it on. Well, that stays solid. That certainly appears to be a problem with the actual board. So disconnect our power supply. Okay, let's see if taking out the disk drive, which is already loose, disconnect its power. And SATA cable. Get a better view of the board. And see if we see any obvious damage, which I do not. Let's see if there's any sign of life after removing the disk drive. Go ahead and reconnect our power supply. No. Still just turning off again immediately. Okay. Let's go ahead and unplug that. Let's see what else could be removed. Just want to remove anything that can be removed. That would be a good idea. Potentially one of these things are shorting it out. Use a smaller screwdriver. There we go. Okay, got out the bit driver here. Let's see if we can get this off. Here I was just praising Microsoft for using a similar screw, but these are a little bit smaller. Just 3 screws holding this on. Seems a bit excessive. But I'm sure they have their reasons. There we go. Not really sure what the purpose of this particular board is. Wi-Fi Max, so that must be the Wi-Fi card. I'm guessing this other wireless chip up front is for the controllers. Probably some Bluetooth chip. We definitely need the front panel to be able to turn it on. Let's see if we have made any difference. Nope. Still shutting off immediately. Interestingly, the fan doesn't even attempt to spin. So it certainly acts like there's a short. Okay. Well, guess we have no other choice but to try and get this board out of here. That's gonna be fun. So with the power disconnected, we'll go ahead and remove our power supply again. And guess we will remove this heat sink. Should separate the heat sink from the CPU. Looks like there may be some clips underneath. And the only way to get to those would be to remove the board entirely from the chassis. So I think in that case, we'll go ahead and remove this front piece, since it's not going to let the board go because it's connected up here at the front. That's that board removed. So what does it take? These will almost certainly be holding the board down. Looks like there's a little clip around this USB port at the front. Let's see if this will lift out now. Aha. There we go. Don't see any damage, although there is some residue. Not sure how well that's coming through. But here in this area, so I wonder if it's just gosh, it looks like some sort of liquid got inside. Though I certainly couldn't say what. Wonder if that's causing a problem. I have to be honest, I don't really understand how these clips work on the CPU fan. Those are certainly pretty strange. I'd like to remove this heat sink. You have to pry these off somehow. I have never seen this type of clip before. I certainly don't want to damage anything. Okay. That's pretty strange. This is definitely loose now. Okay. With that, okay, so now we can get a good look at the board in its entirety. And there is residue all over the place. It's bugs and dust. Huh. So I think what we'll try to do here is see if we can power it up with just this front board connected. Definitely not a good idea to run it without the heat sink, but the processor won't cook immediately, and we'll just unplug it if it starts getting warm. So let's reconnect power and see what happens. No. See, it just shuts off immediately. Well, that is certainly very strange. I think I'd like to test these capacitors that are next to the CPU. Just see if those have a short. Hopefully it's labeled, so yeah, this is the negative side with the stripe. So the negative is closest to us. So if I hook up the voltmeter to one of these capacitors, that is a short of 0.6 ohms. That cannot be right. And this one is the same. I guess I would imagine all of these are probably, at least on these two different planes, these are probably connected together. .9. That certainly seems like a short. Let's test. Just want to see if all of these capacitors are in parallel. Certainly seems like they are. So that can't be right. I think what I'd like to do is there's a number of other capacitors here on the board that have similar markings. These over here appear to be the exact same. So I wonder if those have a short in the same way. So this orientation, negative is still closest to us. Let's take that out of beep. 2 ohms. But the ones next to the CPU, so over here it has 0.5, 0.6 ohms. And over here, getting 0.9, 0.8. So it certainly seems like wherever the short is, it's closer to this side. Okay, let's take a better look at these MOSFETs. So according to the pinout, this is the source, this is the drain. That certainly doesn't seem right. That seems like it's already on. Getting a reading here of the same 0.6, 0.5 ohms between the source and the drain. Let's check all three. Same. Same. That one's a little bit higher at 0.9. I think we can check this as a diode. So if we check between the source and the drain this way, we're getting 0.5 ohms. And the other direction, yeah, one of these is most certainly shorted, or one of the caps is shorted. Fortunately, I do not have a schematic. Okay, I guess that's where we'll end part 1. I'm going to try and find a schematic before I start removing components. I'd definitely like to remove these capacitors first before I attempt to do any SMD work on the board. If it's the capacitors, that would be a much easier fix. Okay, so it's been a couple of days. I've had a little bit of time to think about this. What I decided to go ahead and do was just wash the motherboard a little bit. I used some isopropyl alcohol, a little bit of soapy water, let it dry for a couple of days. Made sure it was free of moisture, but it's still presenting the same symptoms, so not as simple as that. But I think the first thing I'd like to do is go ahead and put this power supply back into its case so it's a little bit less dangerous. So go ahead and move this board out of the way. Let's go ahead and get this back in its little case. So if I remember, I think it goes in like this. This kind of fits in those slots. There's no screws, so it's just held together by clips and a little bit of magic. ahead and get this cover back on as well. If it'll cooperate, that is. There we go. Okay, so that'll be a little bit less dangerous just to have floating around on the bench. What I think I'd like to do is start testing some things with the oscilloscope. I was actually able to find a schematic. I'll link down to that in the description. So it looks like this was leaked at some point. So that'll actually give us a pretty good starting point for figuring out what's going on here. So I think I'll go ahead and reconnect power, and we'll just go ahead and give this another test just so we can prove that we're still seeing the same symptoms. Okay, power button. Yep. Light comes on, it beeps, and immediately turns off. Incidentally, I was testing this and I found that if you press the power button fast enough, and I'm not going to talk over it, but if you press the power button fast enough, it actually appears to do the startup and shutdown noise. So I suspect all of that is being handled over on this side of the board, and it means the processor's not even waking up to perform that particular function. So here, I'll just go ahead and do that right quick. And I'll do it one more time. And if you press it enough, yep, okay. So let's go ahead and break out the oscilloscope and see if we can actually see some sort of signals on these various test points. Found one down here for the CPU core. There's one in this area for the graphics core. Incidentally, the way the power supply is set up here for this APU, application processing unit, which is just the GPU and CPU all in one package, is there's actually kind of a two-phase power supply here that feeds the graphics side, and then a one-phase power supply for the CPU side. So my thought is that if we see the same kind of signaling on all of these MOSFETs and all of these PWM controllers, is that the problem must be somewhere upstream of this particular section here. I've kind of poked around a little bit and I see normal voltages in the places that I expect them to. There's a 12 volt signal here, and that just comes directly off of this connector. And then there's a couple of other standby voltages, and those all seem to be powered up, evidenced by the fact that, you know, this front panel is turning on, and it seems to have enough of the power rails available to try and start the system up. But again, that is just completely failing. So let's go ahead and move this, and let's see if we can break out the oscilloscope. Okay, so I have the oscilloscope on. Hopefully everything is in view well enough. This is about the best angle I can get. So I think the first thing to do is to start testing some things here on the board. So what I wanted to look at, first of all, is that there's this V CPU core test point down here. I'm gonna go ahead and hook up a ground to my test lead here. I guess you have to assume that this is part of the ground. Although, let's make sure just before we run into any problems there. So this should be, and yeah, there we go. 0.1 ohms, so that's definitely a ground. Okay, so we have the scope all turned on. It's in 1 volt per division. So tack on here and see if we see anything come out. That appears to be a big negative. Just to prove that we do have something, we'll test here. So you see that goes all the way up. I believe there was a test point here where we should see 3.3 volts. I don't actually, but I wonder if that's only turned on when the Xbox turns on. Yeah, that goes high for a moment anyways. So yeah, this test point here, this goes high when the console is on. And then there was a number of standby voltages. So this 1.8 standby, so that looks good. That looks good. Yeah, and another 3.3 volt standby. Yep, so that's exactly what we're getting. Okay, so when we turn this on, if I go back to the CPU core test point, see absolutely nothing. Yeah, absolutely nothing. This is the, actually looks like it has two MOSFETs. So this one's driven by ground, and then this one actually is driven by the 12 volts. So we should see the 12 volts over here, and we do. And on this side, we should see nothing, ground. What I want to look at is this gate signal and see if it's ever receiving any power. No. So let's test this one over here in the same way. No. So I think we should look at the gate signal on this one, and since this right here should be that gate signal, and again we see nothing. So let's take a look at the data sheet and see if we can figure out where those signals originate from and see if we can track them down. I imagine it's over here in this chip that's controlling and regulating the MOSFET power. One thing, and looking at the datasheet, and I really have to say this is a cool way of labeling it, is they've broken up the board into quadrants here with A, B, C, D, E, F, and then 1 to 9 along the top here. It actually makes finding things on this board really easy because according to the datasheet, most of this comes from a chip NCP4205. So this chip U9C2 is responsible for basically regulating, it seems like, the control lines to the MOSFETs. Yeah, so this is the regulator, and this regulates power for both the CPU core and GPU core. So we should see, and this is going to be fairly hard to probe because these pens are so small. I'm going to move the camera here, it's a little bit better view. So let's see what we can see as far as test points. There aren't really, but I think what we can do is look at the signals that come out of this chip and go over to this section, which will be a little bit easier to probe. So this is on page 44 of the data sheet, and if I go down to page 47, which is the CPU core output phase, we see that it takes 3 signals in. It takes a 12 volt in, it takes a PWM signal, and then a drive enable signal. And if we're not seeing any of these, then it's certainly not going to be getting any power. And those signals are fed into U9E1, which I believe says U9E. Yeah, U9E2, sorry. So this is U9E2. It takes in those control signals and then regulates that to the two MOSFETs. So it has a drive low and a drive high signal that come out of it. And we're not seeing those signals, so we're definitely not seeing anything come out of this chip, which leads me to believe it's not getting any of the input signals since we checked all of these phases here, and none of them appear to be coming up. It looks like U9E2 gets power from a gated 12-volt signal that goes to capacitor R9E4. So that should be pretty easy to find. So R9E5. R9E4, okay. So on one side of this, we should be seeing 12 volts, although that may only come up with that gated 12 volt signal. So nothing on either side, but let's try power. Okay, so that goes up. Yeah. So we're definitely seeing power come into U9E2. We should also see a PWM signal that's connected to pin 2, and that's impossibly tiny to probe. We should also see a drive enable signal that comes in on pin 3 and goes through resistor R1T3. Okay, so I decided to get a little bit closer here. I am on pin 3 of U9E2, which is the enable signal. And if I cycle this, and I know the oscilloscope's off screen here, but yeah, there is no movement. So, and again, we do see on pin 4 that it is getting power. So it's receiving the VCC, but it is not getting enable. And I would imagine it is not getting the drive signal, the PWM signal either. So I get on pin 2, and this is extremely tiny. So, yeah, no movement on the scope. So whatever's going on, it seems to be upstream of the voltage regulation here. So it's time to look at some other parts of the board. So from this chip, U9C2, if we go back to page 44. Okay, so it receives power on pin 9 VCC, which appears to be a 5 volt that is gated. And we could test that against capacitor C1R2. So, okay, yeah, so here it is, C1R2. So we should see, it says it's gated. So if we look at one side of this and try to turn it on, yep. So that side is ground. Okay, so it's definitely reaching this point. It's getting that gated 5 volts. All right, well, I guess I'm stumped on this one. Let me know in the comments if you have any idea what's going on. I've tested all of the signals. Just to recap, we've tested everything here in the MOSFET power drive for the CPU and GPU. This is not producing any output. It is not getting any of the enable signals or PWM signals that we would expect to be seeing coming from this chip here. I do know that power is being sent to this chip. Unfortunately, the pins are just too small for my scope probe, and I really can't get in there and see. My thought is either this chip is not getting its enable signal. It looks like it has some serial connection on the SM bus, clock and data. I imagine that goes all the way over here probably to this bridge chip. So yeah, short of, you know, trying to lift this off the board and finding a replacement, I'm not really sure where to go from here. So, I don't know. Let me know.